Welcome back. Today is the fourth lecture of the power electronics lecture for the G30 program, G30 international program in Nagoya University. In the last lecture, I have mentioned the boost choppers, the relationship equation for the V input voltage and output voltage. Can you calculate this equation? The chopper, that is a power electronics main, very famous DC converter, DC translate to the DC power. That DC converter is roughly divided in three types. No isolation DC converter that is divided this one. Boost chopper and buck converter and buck boost chopper, buck boost converter. That's the relationship in the input side and outside is indicate that each other, and these relationships main discussion is only the switching timing only. Each power semiconductors switching turn on and turn off timing influence to the output voltage directly. That is the essence of the chopper circuit. Okay, and that is the last lecture I have discussed in the boost chopper. So that is the answer. And please calculate for the buck converter and buck boost converter in yourself. Okay. And but the important thing is this discussion. Of course, this is the very maniac discussions, and this equation is only the current, the inductor current is flow through like this, turn on and turn off, turn on and turn off. This is cycling, so that inductor current shaped like this, but this is a continuous current. We call this mode is a continuous current mode. In this case, we can obtain the output voltage is require obtain this equation. However, if the inductor current reaches to the zero, this continuous current mode, the equation is changed. Another principle. So please mention that this our discussion is only the CCM mode. Okay, that's one. And in your power electronics textbook, usually discussed only this converter, and this converter indicate the equivalent circuit is indicate the figure, and this principle is right. You can easily that discussion is discovered, but the essence of the chopper is how to drive this power semiconductor device. This discussion is very important. So we will discuss the two steps. First step is open loop feed forward control discussion. Today is this one. And the next step is the feedback loop, closed feedback loop control discussion. That is the next step. So today is the open loop, feed forward loop control discussion. For example, is the you can easily image the EV, electric vehicle. In case of the electric vehicle, EV is composed of the battery and chopper and DC motor. In case of the DC motor, the voltage value changed, the power and speed is changed. So the acceleration open or closed, we will discuss the EV's speed can control. This chopper pick up the equivalent circuit is here. And this is the axis, the open and closed value indicates that this voltage. Okay, the variable resistance, the variable resistance point is indicate the acceleration value. And in this chopper circuit, this switch is operate only the turn on and turn off, like a switch, active switch. So this line's signal is required turn on and turn off signal. Turn on and turn off signal is like this. For example, turn on signal and turn off, turn on, like this. If we require this signal through the gate drive circuit, we can operate this power semiconductor device for switch like this one. Okay. So we require this shaped voltage signal. How to generate this signal? We can use the comparator. You know comparator? Comparator is operate for the upper voltage or lower voltage for its output voltage. However, the acceleration voltage the acceleration voltage is almost like a constant voltage. So we will use the triangle waveform and compare it. We can obtain this PWM waveform. Okay, let's analyze for the PWM. The PWM is the pulse width modulation. Okay, we use each pulse width modulations. Later, I will discuss this means. Okay, and triangle waveform is we will use that in the triangle waveform. Later I will indicate that the equivalent circuit of the triangle waveform generator circuit. We can use that comparator. In this circuit output voltage here is required like the oscillation between the 5 voltage and 10 voltage oscillation like this, because in this comparator's voltage ground side, in this case we can obtain this triangle waveform. And more, our acceleration very high frequency for the power semiconductor devices signal is a very high frequency, like for example 1 kilohertz or 100 kilohertz. So as compared with this high frequency, the acceleration voltage almost the same. That the humans moving is very slow as compared with this high frequency. So the almost a constant we can look. So the acceleration voltage, red line is the VC, the triangle waveform is the V triangle, VT. In this case, what is the PWM? Please draw the PWM voltage in your notebook, okay? Please draw one. Okay, let's write the PWM's waveform, and this comparator's output voltage. The do you know the operation amplifiers? This comparator is the operation amplifier. High voltage amplifications or amplification electric circuit. So the compared to the V in a triangle waveform is the lower side, and that with the upper side, VC input voltage, VT input in the minus. So this compared is ちょっと待ってね、ここだから as compared in this term どっち側がいいのかな、こうか、こっち側で、だからここを逆にしたらいいか、sorry, opposite side plus minus, okay, this case, okay. And in this term, the minus side, this side is plus. So the output voltage plus, and the plus voltage is 15 volt because of this using the 15 voltage for the comparator's power source. And in the increase the triangle waveform like this and take over this point. This one is minus side. So upper side, lower side, upper side. Using the comparator, using this comparator, we can obtain the pulse waveforms. from the triangle waveform and almost the DC voltage. And in this case, if we okay, if the axle on, we require the high speed in the electric vehicle. The voltage is upper side. Turn it to the move to the upper side, we can obtain the higher voltage. If we obtain the higher voltage, more higher voltage, we can we can achieve the high speed in the electric vehicle. So high acceleration for the acceleration voltage is higher. Higher means that this DC voltage line is higher, like this. Okay, higher. How about this pulse waveform? Please consider and please write your notebook. The takeover point is here and here. Here.長いな。いっぱいある。ちょっと待ってね。ちょっと汚くなった。リトルね、ダーティーフィガーだけど、ごめんね。I'm sorry. In the upper voltage in the disk voltage, in case of the upper voltage, how about the I will write this. I will rewrite this blue line. ここでこうなって、ここでこうなる。こんな感じ。Like here. As compared with the lower voltage, the pulse width is increased. We mean this term is the turn on term. Turn on term is increase. Increase as compared with the conventional axle voltage. Okay. If we can obtain the turn on term, increase value of turn on term. How about the V out? Please use this equation. We can already obtain one. How about the as voltage as compared with the conventional voltage, acceleration voltage? How about?お腹が空いた。よし。Please calculation. Calculation じゃないな。Please consider. これはね、オールド空手。ウェポンなんですよ。オールドウェポン。で、この、to pierce weapon で。で、defense and attack. Defense and attack. Samurai sword flows through shops. Defense and attack. Opposite side, this ここを狙うね。うりゃって。This is the old karate weapon. Okay, you can understand this one. if increase the turn on turn, the T on and T off is the sampling term and the hold voltage. The TS. This sampling term is almost the same because that is defined only the triangle waveforms frequency only. So this is the same time, but change to only the turn on and turn off term. If you obtain the increased turn on term, the voltage value is increased. Okay? Voltage value is increased. Voltage value increase. That increased voltage that we can reach is the EV speed is higher. That is the open loop choppers control. So what is the PWM control? This is the essence of the power electronic system. Mainly power electronic system is using the PWM control. Because output voltage or many power electronic systems voltage is defined only the turn on and turn off timing. That means we can change only the turn on and turn off timing. We can require the target voltage. So turn on and turn off term changed, we can obtain the target voltage. That timing is changed. Pulse width. That pulse width. Turn on term, pulse width is changed. That is a modulation. We can control the output voltage. Okay? That is a pulse width modulation. Define the output voltage. We can control the pulse width modulation using we can target output voltage. That is the essence of the power electronic system. Okay, but we have discussed only the open loop feed forward one, and later we will discuss the feedback loops discussion. But today we have only the how to generate the PWM pulse. Answer is using the comparator we can obtain this pulse. However, you only turn on term and turn off term, but using the turn on term, that turn off term PW, this line's waveform is the PWM, like this, 15 volt, 0 volt, and through the DC volt drive circuit for the power semiconductor devices. What is the voltage of this line? This line is almost the same voltage, 15 volt. Almost the same voltage. So why we require this gate drive circuit? Almost the same. So you can input directly this voltage directly input. what is occur for the directory connection for this one. We we can, that is it's okay, we think, but that is not okay. We must prepare this gate drive circuit. Why? In the next step, we will discuss this why require this gate drive circuit. Okay? So today's essence is that please understand the PWM controls essence. Okay? Essence is important, very very important thing. In the textbook, your exercise is many circuit circuit analysis, and that's not the essence. Essence is how to generate technology's essence. Technology is the main important is the essence. Okay. This discussion is the essence. Other thing is the know-how. Okay, please divide this discussion. So today's how to generate and how to control the chopper. Next lecture's essence is the why we require drive circuit. Okay, okay. Let's see the next lecture. Okay, thank you.